Okay, so let's move into our next section of the material. So in our next section of material, we're going to be dealing with the cross product. Okay, so the cross product is going to be an operation that we're going to be able to do with two vectors. Okay, now what's different between a cross product and a dot product? The dot product produces a numerical answer. The cross product is going to produce a new vector. Okay, so with the cross product, if we've got vector u cross with vector v. Okay, so the way this is going to work is as follows. All right, so across in the first row, we're going to have the components I, j, and k. In the second row, we're going to have the numerical values coefficients for I, j, and k of vector u. So we can label it as u sub 1, u sub 2, u sub 3. And in row 3, we're going to have the basically the coefficients for the I, J, K components of vector v. So we can write it as v sub 1, v sub 2, v sub 3. Okay. Now, when we go through the examples, I'm going to show you how to evaluate these, but this is kind of the general set. This is the setup for doing a cross product. Okay. Now, with the cross product, we are working in 3D. Okay. So with the cross product, we are going to work in 3D. All right. So a couple of things that we have here. As far as the notes are concerned, we have a definition that says that if I take the cross product of u and v, this is going to be equal to the magnitude of vector u times the magnitude of vector v times the sine of theta times n. And where n is the unit or normal vector. Okay, and we're going to talk about normal vectors more a little bit later on when we are dealing with curvature and tangent vectors and things like that. So we'll talk about the normal vector or the unit normal vector at that time. Okay. All right. Next, we have basically information about parallel vectors. Okay. So basically you have that vector u and vector v are non-zero vectors. So you don't have a zero vector in here. So they're non-zero vectors. So that means that the vector is not made up of 0, 0, 0. Okay. And if two vector u and vector v are non-zero vectors, they're parallel. This is if and only if the cross product of the two vectors is equal to the zero vectors. Okay. So if you do the cross product of two vectors and it's equal to the zero vector, then we know that the two vectors are going to be parallel. And then the last thing we're going to deal with is the area of a parallelogram. Okay, so if you want to find the area of a parallelogram, simple way of looking at it is you take the magnitude of the cross product. Okay, now it can be broken down a little bit in other forms, you can take the magnitude of vector v times the magnitude of vector v times the sine of theta times the magnitude of the unit vector. Or you can look at it in terms of the magnitude of vector u times the magnitude of vector v times the sine of theta. Now, what happened to the magnitude of a unit vector? Well, if you think about a unit vector, so say u is a unit vector. So the unit vector of vector v is 1 over the magnitude of vector v times vector v. So essentially, this piece here is constant. So if I take the magnitude of this piece is a constant, so it's just going to come out. And then I'm going to multiply it by the magnitude of the vector, which is the magnitude of the vector. Well, if you look at this closely, those cancel and give you a value of 1. So that's why that is not in the last piece of that formula. Any questions there? Okay, so let's take a look at examples. So for the first example, it's asking us to do is to find the length and direction of u cross v and v cross u. So for part A, our vectors are defined as follows. Vector u is defined as 2 in the I direction plus 3 in the j direction, and vector v is equal to -1 in the I direction plus 1 in the j direction. Okay, so the first thing we're going to do is to find, we're going to find the vectors. Okay, so we need to start with the first part. We're going to do the cross product of u and v. So if we're looking at u cross v, okay, so again, what we're going to do, and I apologize, I didn't give a name for this. When you are dealing with, basically you're dealing with a matrices with straight lines, this is referred to as a determinant. So what we're going to do is we're going to fill in the determinant. So again, for the top row of the determinant, it is I, j, and k. For the second row of the determinant, it's going to be the coefficients of vector u. So it's going to be 2, 3. Now, for vector u, we don't have a k component, so the coefficient is 0. All right, and then for vector v, it's going to fill in for the third row. So we're going to have -1, 1, and 0. Okay. Any questions there? Okay, so before I work out this problem, I'm going to go over a couple of pages and explain how to evaluate a determinant. Okay, so evaluating a 3x3 determinant. Okay. All right, so the method that we're going to use in order to evaluate is something referred to as cofactor expansion. Okay, also known as the minor method. Okay, also known as the minor method. So the way this is going to work, okay, so if I have a determinant with the value, and I'm just going to use letters here. So this is A, this is B, C, D, E, F, G, H, I. Now, for the purpose of, for what we're always going to do, we're always going to expand off the first row, okay? And then we'll start alternating columns, okay? So rows go left to right, columns are up and down, okay? So what we're going to do first is we're going to expand off the first row and the first column. And I'm going to use kind of some light colors to mark what I'm doing. So I'm expanding off of this row and this column. Now, the value that's crossed out in both situations is the number that's going to go out front. And then what's left is you're going to have a determinant of values. And the determinant of values are the things that are not crossed out. So the letters that are not crossed out are E, F, H, and I. And what we're going to do is evaluate that determinant and multiply it by A. Okay. Now, in a matrix, each position in the matrix holds a position. So this first position holds a position of positive. The second position holds a position of negative. The third is positive. And it alternates signs throughout the whole matrix. So this would be negative, positive, negative. This would be positive, negative, positive. Okay. But since we're doing everything off the first row, we're only worried about those signs. So when I move to expanding off the first row, but this time the second column, okay? So what happens is that since we're expanding, we're going to multiply by B, well, that position holds a negative sign. So we're going to put minus, and then we're going to have B times, and we're going to have a determinant that is formed. Now, keep in mind that when I expand off a new row, that mark out of that column is no longer there. Okay, so the letters that I have left are going to be D, F, G, and I. So that's the determinant that I'm going to evaluate. Okay, and now I'm going to do this one more time. So again, I'm going to expand off the first row, but this time I'm going to go to the third column. Well, where I see crosses at is at C. Well, we know that C holds a sign position of plus. So I'm going to have C times the determinant is going to have the values of D, E, G, and H. So this is how we evaluate a 3 determinant by the cofactor expansion. And trust me, you're going to get enough practice with this, okay? Or if you've had the situation that you've taken linear algebra, you've probably have been exposed to this already. Okay? Any questions? Okay, so what I want to do now is go back to the problem that we were dealing with and work that out. Okay, is everyone done with this page? Okay, so let's go back to our page that we were working on. So it's page 4. Okay, all right. So if we're going to do the expansion for this, okay, again, we're always going to expand off the first row, and then what we're going to do is alternate columns. Okay, so if we do first row, first column, all right. So notice that I is the one that is basically crossed out in both situations. So I is going to go at the end. Okay. Now, our determinant that is left are the numbers that are not marked. So it's going to be 3, 0, 1, 0. Okay. Any questions there? All right. Go ahead. Okay. All right. So next, we're going to expand off the first row, but now we're going to move to the second column. Now, when we move to do the first row, second column, the J in that position holds what sign? It's negative. So what we're going to do is put minus. All right. J is going to be what we're going to multiply by. And then the determinant, if we go across, the first number is going to be what? It's going to be 2. The second number is what? 0. Now we're going to go to the second row. The first number is going to be what? -1. And the second number is what? 0. Okay. All right. So now what we're going to do, again, we're expanding off the first row, but this time we're going to do the third column. Okay. Now in the third column, for the position of K, it holds a sign that is what? It's positive. So we're going to do plus, and we're going to have K, and then we're going to have this determinant that's formed. So for the determinant, what values do we have? So starting on the first row, starting on the left, first number is going to be what? 2. The next number is what? 3. All right, second row, first number is going to be what? -1. And then the final one is going to be what? 1. Okay. All right, so everyone understand how we got all those numbers? Okay, so what I'm going to do is I'm just going to take this, I'm going to write it on a new page so I have enough room to do all the work for it. Okay, so I'm going to have, starting off, 3010 times the I component minus, next I'm going to have 2 -100 times the jth component plus, then I'm going to have 2, 3, -1 times the k component. Okay. All right. So to evaluate a 2x2 determinant, it's pretty nice. It's not, and it's pretty straightforward. So what you do is take diagonal going down, multiply it minus the diagonal going up. So it's going to look something like this. So when I write this out, it's going to be 3 times 0 minus 1 times 0. And then that's the I in the I direction. Minus. Then for the next one, it's going to be 2 times 0 minus -1 times 0. And that is in the j direction. Plus, for the last one, it's going to be 2 times 1 minus -1 times 3, and that's in the k direction. Okay, so if I evaluate this, what value will I get?
$5K.
You get what?
I mean, like $5K, like overall.
Yeah, so you're going to get
sorry,
5K overall. Okay, so the first piece, you're going to get 0 in the I direction, minus next piece, you're going to get 0 in the j direction, plus last piece, you're going to end up with 5 in the k direction. Or would you simply say 5 in the k direction? Okay. Any questions there? So now we found the vector. So once we found the vector, the first thing we're going to do is to find the length. Okay, so the length is just asking us to find the magnitude. So we're going to find the magnitude of u cross v. Well, that's going to be just the square root of 5 squared, which is just going to give us 5. Any questions? Okay, so next we're going to do with the direction. Okay, so the direction is just a unit vector. So we're going to do 1 over the magnitude and then times it by the vector. Okay, so the magnitude we've established was 5. The vector we established was 5 in the k direction. So our vector would be just k. Any questions? Okay, so let's look at the other component of this. So right now, all we've done is u cross v. So now we're going to do v cross u. So if we look at v cross u, okay, so again, it's going to create a determinant. So always keep in mind that the cross product is going to produce a new vector. So across the top, we're going to have I, j, k. Okay, so for vector v, the coefficients we're going to use are -1, 1, and 0. For vector u, we're going to use the coefficients of 2, 3, and 0. Okay, so if we do our cofactor expansion off of this, we're going to have a determinant form times vector, the direction in I. So what numbers go inside of this determinant?
So 1030.
Okay, so 1030, very good. All right, then the next position is going to be the sign up for the next term is going to be what?
Negative.
Yes. All right, then we're going to have a determinant form and it's going to be times in the j direction. So what values go in the determinant?
Negative 1020.
Yes. Okay. Now, the third position holds a sign that is what?
Positive.
Positive. So we're going to have a determinant times vector k. So what goes inside the determinant?
-1, 1, 2, 3.
Okay. And this is what we have. All right. So now what we're going to do is evaluate. So if I evaluate this first determinant, what value will I get?
0.
Okay. In the I direction minus. If I evaluate the second one, what value will I get?
0 in the j direction.
Good. Plus, and if I evaluate the last one, I'm going to get what?
-6.
Ooh, careful.
Oh, sorry.
So if we evaluate the third determinant, what value do we get?
A +6.
No. So let's think about it. You're going to do 3 times -1 times 3 minus 2 times 1. Yes, it's going to be -5 in the k direction. Okay, it's going to be -5 in the k direction. Right? And I know what you guys were doing. You were taking 2 times 3 and ignoring that the way that do this. So just be cautious when you're doing this. So you're going to get -5 in the k direction that um, for that vector, the cross product of those two vectors. Any questions there? Scroll up, scroll. Do you need me to go back a page? You're welcome. Okay. Are we ready to move forward? Okay, so let's continue. So we found that basically our vector for v cross u is going to be -5k. So if we find the length, we're looking at basically the magnitude of v cross u. So that's going to be the square root of -5 squared. So what would our answer be? Yes, it's going to be 5. And then for the direction, we're looking at the unit vector. So we're going to take 1 over the length times the vector. And the vector that was formed was -5k. So we're going to end up with -k. Okay. Now, this is important for this because what it tells us is the following. Okay. So if I'm looking at v cross u, it's equal to the negative of u cross v. Okay. So if I'm looking at v cross u, it's equal to the negative of u cross v. Any questions? Okay, so next. This is part B. So this time we're going to look at new vectors. So vector u is defined as 3/2 in the I direction minus 1/2 in the j direction plus 1 in the k direction. And then vector u is equal to 1 in the I direction plus 1 in the j direction plus 2 in the k direction. So the first thing we're going to do is to find u cross v. So the first thing we're going to do is to find u cross v. Okay, so if we do u cross v, the first row is going to be what? No, that's not going to be the first row.
IJK?
Yeah, it's IJK. Now, the second row will be u. Okay, so we're going to put in 3/2, negative 1/2, 1. And then the third row will be the coefficients for vector v. So we're going to 1, 1, 2. Okay. All right. So what I'm going to do is I'm going to give you guys a couple of minutes to find what this vector will be. Excuse me. Okay, so let's just take a look and make sure you set it up correctly. So for the first one, you should have the determinant that is going to be negative 1/2, 1, 1, 2 times the ith minus, then you're going to have the determinant of 3/2, 1, 1, 2 times j plus, then you're going to have the determinant 3/2, negative 1/2, 1, 1 times k. Okay, so everyone get that as far as the setup is concerned. Okay, so when you evaluate it, what did you get for the first value here?
-2?
Yes. So negative 2 in the I direction minus, What did you get for the second one?
2J.
2 in the J direction, plus, and then for the last one, you got what?
2 as well.
Okay,
Yeah, 2K.
so 2 in the K direction. All right. So did everyone come up with this for the vector? Excellent. Okay, so we got this as the vector. So next, we want to find the length. Okay, so that's basically, we're looking at the magnitude of this cross product. So if we look at the magnitude, okay, so essentially what we're going to have is going to be the square root of -2 squared plus 2 squared plus 2 squared, which is going to give us the square root of what?
One.
How much?
12.
Yes. Okay. Which we can reduce to 2 times the square root of 3. Any questions there? Okay, so the last thing we need to do is to find the direction. So for the direction, basically we're looking at the unit vector. So we're going to do 1 over the length, which we said was 2 square root of 3, times. Then we're going to multiply by the vector, which is -2 in the I direction, minus 2 in the J direction, plus 2 in the K direction. Now, you can clean this up a little bit, so we could write the answer, the final answer, in -1 over square root of 3 in the I direction, minus 1 over square root of 3 in the J direction, plus 1 over square root of 3 in the K direction. And this will be our vector in the direction. Any questions? Okay, so next, what we need to do is define V cross U. Now, in order to do this, we're going to use a property that we just established from doing problem A. So if we use that property that we established from doing part A, what will V cross U produce? What is the vector?
Positive 2I, positive 2J, and negative 2K.
Yes. Okay, so that would be the vector that's going to produce, because you remember that we established, and let me just go back to that real quick, that V cross U is equal to the negative of U cross V. So since we already know U cross V, all we got to do is multiply it by -1 to come up with the new vector. Okay, so that saves us a lot of work right there. All right, so now we can find the length. Now, is the length going to change? No, So we know it's going to be 2 times the square root of 3. And then for the direction, all right, it's going to be done the same way. So it's going to be 1 over 2 times the square root of 3 times. Then we're going to have, in this case, we're going to multiply by 2 in the I direction plus 2 in the J direction minus 2 in the K direction. So we're just going to end up with 1 over the square root of 3 in the I direction plus 1 over square root of 3 in the J direction minus 1 over square root of 3 in the K direction. Okay. Any questions there? Okay, so what we're going to do next is to move to the next example, right? So in the next example, we have this. We're told that point P is defined as 1, 1, 1. Point Q is defined as 2, 1, 3. And point R is defined as 3, negative 1, 1. Okay. So for the first part, what we're going to do is we're going to find the area of the triangle determined by the points. Okay, so we're going to find the area of the triangle determined by the points. And the points are, of course, not what I'm writing. Oops, change colors. P, Q, and R. Okay. All right. So what we're going to do first is, since we are dealing with a triangle, we got to think about how to find the how we're going to do the area for this. Okay. Now, do we know how to find the area of something already? Or we're given information in the notes where we're given information on how to find the area of something? Yes. So what was that we were given the formula for finding the area of?
The area of a parallelogram?
Yes. So we were given in the notes the formula for finding the area of a parallelogram. Okay. Now, what's the relationship between a parallelogram and a triangle as far as area is concerned? So what's the relationship between the area of a parallelogram and the area of a trapezoid? I mean, area of a triangle. All right, the area of a parallelogram is twice of the triangle. So since we know we know how to find the area of a parallelogram. So in order to find the area of a triangle, we know it's going to be just a half, right? So for the area in this figure, it's going to be half Okay, and we know to find the area of a parallelogram, it's going to be the magnitude of the cross product. Okay, but here's our problem now. Do we have a vector u and a vector v? No. But can we create vectors u and vector v? Yes, we can. Okay. Now, the way we're going to create these vectors, okay, in order to help us out, we always want to start off at a same common endpoint. Okay. So the way we're going to look at this, so first thing we're going to do is create the vectors. So we do need to create two vectors. So we need to create a vector, let's do PQ, and a vector PR. Notice I'm keeping the same start point, but a different end. And that's going to give us two sides. Okay, that's creating a vector for two sides of this triangle. And that's all we need. All right, so if we create the vector PQ, what's going to be the first coordinate? Well, what's going to be the coefficient of the I for the ith direction? So what value will we get? We're not going to get 2. So you got to remember, how do we compute the vector? Yes, it's going to be 1 because we have to subtract the values. Okay, then we're going to have plus the coefficient for the j component is going to be what? 0. Plus the coefficient for the k component is going to be what? 2. Okay, so one thing I have to tell you is that when we talked about creating vectors earlier, it's coming back into play. So you have to make sure that you understand the stuff that we did earlier, because it is going to come back into play a little bit and later on. Okay. All right. So next, we're going to deal with the vector PQ. Okay. I mean, not PQ. We just did PQ. We're dealing with the vector PR. Okay. So for the vector PR, what is going to be the coefficient for the I term? It's going to be 2. Plus, what's the coefficient for the j term? It's going to be -2. I'm going to put that in parentheses to make sure we don't mess it up. Plus, and what's going to be the coefficient of the k term? 0. All right. And here's the thing. We like when we have zeros in there because it does make calculations easier when we're getting ready to do, when we're going through the process of doing the cross product. Okay. So any questions there on how we found those two vectors? Okay, so next, we've found our two vectors. So what we're going to do next is we've got to do the cross product of these two vectors. Okay, so if we set this up, we're going to have our I, j, and k. All right, and then our values are going to be, got to go back and look, 1, 0, 1, 0, 2. And then for the second one, it's going to be 2, -2, 1. Excuse me, 2, -2, 0. Okay, so if we evaluate the determinant, we're going to have a determinant form that is going to have the values of 0, 2, -2, 0 in the ith direction, minus. The next determinant is going to be 1, 2, 2, 0 in the j direction, plus. And then the final determinant is going to be 1, 0, 2, -2 in the cake direction. Any questions there? Okay, so next, what value will we get right here? Yes, we're going to get a value of 4 in the I direction minus what value do we get here? Careful. Yes, it's going to be -4 in the cake direction plus, and then what value do we get here?
-2.
Yes. And oops, in the cake direction. So I'm just going to clean this up. So it's going to be 4 in the I direction plus 4 in the J direction minus 2 in the K direction. So the last thing we need is we're going to find the area. And that's going to be 1/2 the magnitude of the cross product. Okay, so it's going to be 1/2 times the square root of, it's going to be 4 squared plus 4 squared plus -2 squared. So we're going to have 1/2 times the square root of, when we evaluate the expression under the radical, what are we going to get?
-36, I guess.
Okay.
Yeah.
We get 36. So we're going to have 1/2 of 6, or we get a value of 3. And that would be the area. Any questions? Well, for this, you don't have, when you are doing this, you don't have to, you don't need to create a vector for all sides. You only need to create a vector for 2 of the sides. Okay. So essentially what I did was, here's point P, here's point Q, here's point R. So what I did was create the 2 vectors, these 2 vectors here, and do the cross product. Okay. And the cross product is going to create a new vector. Okay. And since it's only a triangle, I know that it's half of the parallelogram, the area of the parallelogram. So I really don't need this to know what that vector is for the third side at all in order to do this. Okay. Any questions? Okay. All right. So next, what we're going to do, and this is part B, we want to find a unit vector perpendicular to the plane PQR. So we're going to find a vector that is perpendicular to the plane of PQR. Right? So essentially what's happening here is we have this plane, and what we want to do is to find a unit vector that is perpendicular to this. Okay, so we're going to find a vector that when it cuts through the plane, and that's a bad drawing on my part, that it's going to create right angles. Now, when we do this, okay, our unit vector, okay, so since we are doing in respect to this plane, well, we know that the plane is a triangular plane. So in order to do this, we're going to do 1 over, okay. Now, we've already done the work for this, okay, so there's no extra work for this. So for the unit vector, it's 1 over the length times the vector. So the length will actually be the cross product that we just did. And then our vector is going to be the vector that we created. Okay. Now, that we want it perpendicular. Okay. Well, we got to be careful about this, because when we are dealing with this, it can be two different situations. We can look at it at the vector coming with it with kind of a positive slope, and it's perpendicular, but it could also have a negative slope and be perpendicular. So for this particular unit vector, we've got to put plus or minus on there, because there's actually two vectors that could work for this. Okay, so if we take a look at this, we're going to have plus or minus. All right, we already calculated the magnitude of PQ cross PR. So what is that equal to? And be careful. So what is that magnitude equal to? Yes, it is 6. So we're going to have 1/6 times. Now, we've already found the vector PQ cross PR. All right. So we said the vector PQ cross PR was equal to what? So 4 in the I direction plus 4 in the J direction minus 2 in the K direction. All right. So this will create our unit vector. Okay. Now, I can simplify it a little bit. I can divide, everything's divisible by 2, but I really don't want to multiply it out. Okay. If I do multiply it out, I have to write it as 2 separate vectors. I don't want to do it, but this is kind of a simplified form of writing this a unit vector that's perpendicular. Okay. And again, the reason why we have to put the plus or minus is because we have to think of it in terms of it could have a positive or it could have a negative slope in an aspect, okay, and be perpendicular to that plane. Okay. Any questions? Okay, so we do have more problem in this section, but before we dive into that, let's do a 5-minute break. Give you a chance to digest what we've gone through so far, and give you a chance to get up and walk around for a little bit, and then we'll resume at 12:05. Okay. Okay, so let's continue on. So let's deal with our last problem that we have here. So the last example in dealing with the cross product material is asking us to find the area of the parallelogram whose vertices are given. So we have A at 0, 0, B at 7, 3, C at 9, 8, and D at 2, 5. So basically, this is looking something like this. So you've got 0, 0, you've got 7, 3, you've got 9, 8, which is going to be probably somewhere up here. And then you've got 2, 5, somewhere right here. So here's A, here's B, here's C, here's D. So you have kind of a rough looking sketch of what this parallelogram will look like. Okay, so essentially what we need to do is to create two vectors. Okay, and we do want to start at the same endpoint. Always my recommendation is to start what the first letter is. Okay, so my first one, I'm going to do AB. All right, and what would the other vector be? So if AB is one vector that we need to find, what would be the other one? Okay, but keep in mind you always want to start with the same endpoint. Have one endpoint that is common. So AD. Okay. Now BC will probably work also, but again, I try to make it easy, so I always start from the same one and not choose a different one. Okay, so whatever I start with the first one, I want to start with it on the second one and end at a different endpoint. Okay, all right, so if I look at this, okay, so for the vector B, so what's going to be the coefficient for the ith component? It's going to be 7 and then plus, and then we're going to have 3 in the j direction. Okay. All right. Then for the vector AD, what is that vector going to be? Here in the ith direction plus 5 in the j direction. Okay. So since we are trying to find area, what should I do next? Yeah, I'm going to find the cross product between these two. So I'm going to find AB cross with AD. Okay, I'm going to find AB cross with AD. All right, so what I want you to do, let's move over to another page, AB cross with AD. So if we set this cross product up, across the first row, we know it's going to be IJK. All right, for the second row, what values will we use?
Seven three zero.
730. And then for the third row, what values will we use?
250.
Yes. Okay. All right, so I'm going to give you a couple of minutes and let you find what that vector is going to be. Okay. So, oops, get this a little bit better. So, is this what you came up with as far as the vector is concerned? And if I can write the correct letter at the end, it will make sense. How about K there? So this is our vector, and if you simply just wrote it as 29K, that's fine also, okay? So the last thing we need to do is to just find the magnitude of this, the cross product. So if we find the magnitude of this, we end up with the square root of 29 squared. So we get that the area is going to be 29. Any questions? Okay. All right, so that is it with the information over the cross product. Okay. Give me 1 second. Let me put up the slide for, let me put up the stuff for section 9.5. I do want to put that up because I want to talk about the formulas here on that real quick. Give me a second. I've got to download it real quick. Okay, so I just want to talk about the formulas instead of me just reading them out loud. I can show them this way so I can point at things. Okay, so we're going to be dealing with lines and planes in space. Okay, so the first thing we're going to talk about is dealing with a vector equation for a line. So a vector equation for a line L through the point p sub 0 is equal p sub 0, which is defined as x sub 0, y sub 0, z sub 0, parallel to vector v is, we write it in terms of r of t, is equal to r sub 0, which is your basically kind of your initial, t, and then times vector v, where r is the position vector at a point p defined as x, y, and z on L, and r sub 0 is the position vector of p sub 0 at x sub 0, y sub 0, z sub 0. Okay, so basically what we're going to be doing here, okay, since we've introducing t into this, we are going to be dealing with writing equations of lines in parametric form, okay, in a way, okay, but we're writing it like this, but then we can pull it apart in parametric form. So the standard parameterization of a line through point p sub 0 defined as x sub 0, y sub 0, z sub 0, parallel to v equals v sub 1 in I direction plus v sub 2 in the j direction plus v sub 3 in the k direction is. So for x, it's equal to x sub 0 plus t times v sub 1, comma, y is equal to y sub 0 plus v times t times v sub 2, plus, and then z is equal to z sub 0 plus t times v sub 3, where t is between negative infinity and infinity. Okay, so this is the form of a parametric line written out in all this component. So we'll talk about how to write it in this form, and then once it's in this form, pull it out into the separate x, y, and z forms. Okay. Next, the distance from a point S to a line through P parallel to vector V. Okay, so to find the distance, it's going to be equal to the magnitude of the cross product of PS and the vector V divided by the magnitude of vector V. Okay, any questions there?
What would a PS be?
PS is basically you've got a point and it's through another point P. So you've got a point S and a point P. So what you're going to do is create a vector that is the vector PS. Okay. Any other questions? All right, so next we have a line, an equation of a plane. It says the plane through the point defined as p sub 0 is defined as x sub 0, y sub 0, z sub 0, normal to, basically we have a normal vector that is a in the I direction plus b in the j direction plus c in the k direction, has a vector equation of n dotted with p sub 0 times p is equal to 0. Okay, so this is just a vector form of it, the way it will look, but this is not a workable form. So what we're going to do is to look at two different forms. So if we look at it in terms of component form, we're going to have a times x minus x of 0 plus b times y minus y sub 0 plus c times z minus z sub 0 is equal to 0. So this is a more workable form that we use. Now, the next is just a simplified version of this. So simplified version is that we're going to have a times x plus b times y plus c times z is equal to d, or d is equal to a times x sub 0 plus b times y sub 0 plus c times z sub 0. Okay, and again, this will make more sense when we go through the examples. Okay. Any questions there? Okay, so what we're going to do is to start into the section. We're not going to get done with all the examples, but I do want to get started in the section. Okay. Hey, Con, if you don't mind putting your mic on mute, please. Thank you. All right, so let me switch back. Okay, and let's take a look at the first example. Okay, so the first example in this section, and again, this is referred to lines and planes in space. Okay, so for the first example, we have find the parametric, equations for the line. Okay, so for the first one, we're told that it's a line through, and we have the point. Let me back up a little bit. Got ahead of myself on writing. So we've got a point P, which is defined as 1, 2, 4, and a point Q, which is defined as -1, 0, 1. Okay, so the way we're going to do this, all right, so basically to write our equation of a line, okay, we're going to have that R of t is equal to R sub 0 plus V sub 0 times t. Okay, so R sub 0 is going to be basically our start point. V sub 0 is going to be it's going to represent our slope. Okay, V sub 0 is going to represent our slope. So the first thing we're going to do is to find V sub 0, which is our slope. Well, in order to find our slope, okay, that V sub 0 is going to be a vector. So we're going to create a vector for the slope, which we're going to define as PQ, vector PQ. Okay, so if we create vector PQ, we're going to end up with, for the I component, it's going to be -2 in the I direction. For the J component, it's going to be -2 in the J direction. And then for the K component, it's going to be, I did some bad miswriting, my fault. And I'm sure you're looking at that and it's like, that's not for what that wrote. How about -1 right here? Okay. And then that's going to be +2 in the K direction. Okay. So for our vector, not for our vector, but more for our equation for our line, which we're going to define as R of t, okay, it's going to be equal to R sub 0, which is our initial point, and your starting point. So it's going from this point to this point. The line is going from through this point to this point. So this is going to be the first point that it's going to go through. So we're going to use that as the start point. So we're going to have 1, 2, -1, okay? And then we're going to add it to, okay, we're going to have the vector V sub 0, which we just created, which was -2, -2, and 2. And then we're going to multiply that by t. So what we're going to do is to pull this apart. Okay? Is everyone okay so far? Okay, so what I'm going to do is rewrite this piece here on the next page, and I'm going to pull it apart. So we're going to have that r of t is equal to 1, 2, negative 1, plus the vector that we just found, which was negative 2, 2 times t. So for x, okay, so when we write the parametric equation for the x, it's going to be basically, if you think about it, it's the x coordinate and then the first coordinate of the slope. Okay, so it's going to be 1 minus 2t. Then my equation, parametric equation for y, is going to be 2 minus 2t. And then my parametric equation for z is going to be negative 1 plus 2t. Okay. Any questions there? Okay. All right. Let's look at another example. All right. So our next example is this. And this is just part B. We have a line through the point 3, negative 2, 1, and it's parallel to the line x is equal to 1 plus 2t, y is equal to 2 minus t, and z is equal to 3t. Okay, so we're going to write an equation of parametric equations for a line that goes through this point and is parallel to this given line. Okay, so if we take a look at this, r of t. Okay, so again, it's going to be r sub 0 plus v sub 0 times t. All right, so r sub 0 is going to represent our starting point. So what is our starting point based on the information that we have here? Yes, it's going to be 3, negative 2, 1. And that's going to be our starting point. Plus, okay, so let's remember some things about lines. So since we know that the line, the parametric line that we're writing the equation for is parallel to the given, so what do we know about parallel lines? So what do we know about parallel lines? They have the same slope. So what I have to do is, based on the given line that I have, I've got to be able to identify the slope. Okay, so if we take a look at the given line that we have, what would the slope be? What values? Right, it's going to be 2, negative 1, and 3. Because if you think about it, and this is kind of the reason why, and we go back a slide, this is one of the reasons why I wrote this in this form, so that you can see how this broken up, it breaks into this, and you can see the connection working back and forth on this. So that's basically what we're doing. You notice that all the numbers that are in front of t were the vector that we created over here. So that's what's happening here. So all the numbers in front of t end up being that slope portion of our line. Okay? Does everyone understand that? Okay, so Now, all I'm going to do is to pull this apart, okay? So I want to write a separate equation for each of the variables. So for x, what would the parametric equation look like? Yes, it'll be 3 plus 2t. For y, what would the parametric equation look like? Yes, negative 2 minus t. And then for z, what would the parametric equation look like? One plus 3t. Good. Okay. Any questions? Okay, so we still got a couple of minutes left, roughly about 18. I'm not going to push it because I know that the next problem is going to be take a little bit of work on it. The next part of this problem is going to take a little bit of work. So I'm just going to hold off, and this is where we're going to start on Thursday in class. Okay, so we'll start on part C of that first example on Wednesday. All right. Any questions? Okay, so for homework, you're going to do the cross product homework. Okay. Also, quiz 1 is available starting at 1 p.m. It's due Thursday by 11 a.m. Okay. So quiz 1 is available starting today at 1 p.m. and it's due Thursday by 11 a.m. Okay. Any questions? Also with the homework over the cross product, I don't think I have the solutions posted yet, but I'll be working on that, and hopefully I should have those ready tomorrow morning. All your quizzes, I will try to get graded as quickly as possible, but just keep in mind that since they're due basically when class starts, I won't even entertain grading them until after that. Okay. And with the quizzes, when I do grade them, I'll submit your work back to you with the corrections on there. Okay. Any questions? Okay. If you do have any questions, please let me know. Always remember, you can come in during office hours to ask me questions, or you can always email me. Okay. All right. You guys have a great rest of your day, and I will see you on Thursday.